Hi boys and girls, welcome to your lesson on gas pressure for week 3. So for this lesson we'll be looking through the following facts from your fact book. We're talking about what gas pressure is, an equation for pressure, and we'll be looking at the effect of temperature and volume on the pressure of gases. We'll be looking at Boyle's law equation, and we'll be explaining why work done on a gas leads to a temperature increase on the gas. Before we do that, let's have a starter question from last lesson. These are your starter questions. Give yourselves about 6 or 7 minutes, and we'll be going through the answers in just a second. Okay, so for question number 1, these are the answers you should have got. What is the definition of latent heat? Is the amount of energy needed to change the state of 1 kilo of something without a change in its temperature. Number 2, two types of latent heat. Latent heat of fusion is where we get the melting phase, and latent heat of vaporization is where we get the boiling phase. Number 3, the equation for latent heat. E equals ml. Energy in joules equals the mass in kilograms times the latent heat in joules per kilogram. Remember, the latent heat equation applies for both types of latent heat, the fusion and the vaporization. Question 4. At which parts of the heating graph would you find latent heat? It's at the flat part where there's no change in temperature. What's happening at these parts? Well, we're getting a change of state because energy from the fuel and from the heating is being transferred into changing the states, breaking the bonds, rather than increasing the temperature. How would you calculate internal energy? Well, internal energy equals kinetic energy of particles plus the potential energy of the particles. Any increase in the kinetic energy of the particles or the potential energy of the particles leads to an increase in internal energy, which in turn would lead to an increase in temperature for the kinetic energy part. Number 7, arrangement and movement of particles in a gas. Well, they're very far apart, they're spread far apart, and they move in random directions at random speeds. That last point is quite important because we'll be talking quite a bit about that in our lesson today. Well, let's make a start with gas pressure. We know that gas particles are moving in a random motion at random speeds, and they're very far apart. We should also know that as the temperature increases, we provide those gas particles with kinetic energy. So the average speed of the gas particles increases too. They move faster. Why is that important? Well, when gas particles collide with a surface, for example, if you think about gas in a container, the gas particles are constantly colliding with the surface of the container. And every time they collide with the surface, they exert a force on that surface. The force is at right angles to the surface. The net force acting over the total surface area is what we call gas pressure. In your books, can you please get that bullet point down and anything else that you feel you need to? The gas pressure can be increased by doing the following to the collisions. So remember, gas particles collide with the surface. We can either make those collisions more often, more frequent, which will increase the pressure, or we can make those collisions have more energy, so they collide with a larger force. How can we deal with those? Well, before we get there, we know that pressure on a surface depends on the force applied over a certain area, and that is given by this formula. Pressure equals force over area. I'm not going to go into this equation in more detail right now. We'll be going over it in more detail when we talk about pressure in our force topic. But at the moment, if you'd like to, just make yourself aware of this, make yourself familiar with this equation. Pressure is measured in pascals. Force is measured in newtons. And area is measured in meters squared. So this tells us the pressure depends on how much force is acting over a certain area. Gas pressure and temperature. For a fixed volume of gas, when the temperature increases, pressure increases, because particles collide more frequently and with more energy. Let's explain this. The diagram on the left shows a container, a white box of some sort, with some gas particles inside. The yellow dots represent gas particles. The arrows, red and blue inside, represent the motion, the movement, direction of those gas particles. And the arrows, the sort of greeny arrows around the box, show the force. Force is represented by an arrow. Bigger the arrow, the bigger the force. So this is telling us that in this diagram on the left, where we have low temperature, so it's colder than the one on the right that will be coming up, so it's a low temperature, those particles are moving around with random speeds. However, only a couple of them are colliding with the surface of the wall. That's telling us there's quite a low force of collision and quite a low force on the container wall, which is telling us because the collisions have low energy, low force, gas pressure is also low. So when temperature is low, the particles are not colliding as frequently with the surface, and if they do collide, they're not colliding with that much force. Gas pressure is low. The diagram on the right now shows us what happens when we have a higher temperature. The gas gets heated up. The particles still moving around, but now the red arrows show that they are colliding successfully with the surface more often. And they're colliding with more energy, with more force. So the force exerted is larger, represented by the greeny arrows. We can see two things have happened when we increase the temperature. The gas particles have collided more frequently with the surface, and they've collided with more energy. So larger force, larger pressure. In your books, if you'd like to copy this down, please do, but most importantly is the writing at the top in the yellow box. That's very important. As gas temperature increases, gas pressure increases because gas particles collide more frequently and with more energy. What about volume then? The volume of the box. Well, for a fixed temperature of gas, that's very important because if you remember when we do experiments, we have control variables, etc. The temperature of the gas in this case should be kept constant because we've seen from the previous slide the temperature can affect pressure. So when we have a fixed temperature, constant temperature, well, in that case, if the volume of the container or the gas increases, the gas pressure decreases because particles collide less frequently. And we'll see that happening in a second. Boyle's law tells us that volume of gas and the pressure of the gas are inversely proportional, and we'll have a look at that in just a moment. So here's that box again with some gas particles. We can see inside they're colliding, not so much, but whatever. We've got a small volume. Collisions are higher than what we'll see in a second. Gas pressure is high here. In this case, we've increased the volume. There's more space now. More space means that the gas particles are colliding or less likely to collide with the surface. If they're less likely to collide, well, there's less frequent collisions. So less frequent collisions, less force on the surface, less pressure. As gas volume increases, gas pressure decreases. And that's a very important fact to learn. Why does that happen? The gas particles, when the volume increases, are less likely to collide with the surface, and therefore there are less frequent collisions, therefore gas pressure is low. An important point to note here is that the volume has nothing to do with the energy of the collisions. Energy of collisions only happens if we speed up the particles, which only happens if we increase the temperature. So in this case, volume, we're only talking about the frequency of the collisions. In your books, I'd like you to at least get the definition, explanation in the yellow box at the top. The diagrams are helpful if you would like to do that. So here's a midpoint quiz. Give yourself 5 minutes, pause the video, and answer these the best as you can using full sentences with good explanation, please. Here's the answers that you should have got. Question 1. What happens to average speed of gas particles as temperature increases? Well, particle speed increases. They have more kinetic energy. What happens when gas particles collide with a surface? They exert a force at right angles. Two things we can do to gas particle collisions. Well, we can increase the force of the collisions. We can increase the frequency of the collisions. Explain what happens to gas pressure as temperature increases. As temperature increases, the particles gain the kinetic energy through the heating. They move faster. When they move faster, that means that they'll collide more often with the surface, which increases pressure, but also they'll collide with more force, more energy, so that also increases pressure. As the volume increases, particles have more space to move around. They're less likely to collide. Collisions are less frequent, so pressure is also low. Now, I mentioned a couple of slides ago that gas pressure and volume are inversely proportional. Inversely proportional is a term that comes up quite often in physics. It just means when one thing doubles, the thing that's affected by it halves, or any other ratio. Basically, they are in proportion, but opposite proportions. So, as the volume increases, pressure decreases by the same ratio, and vice versa. And this equation is very important. P is your pressure in pascals, V is your volume in meters cubed. What that tells us is P times V is a constant. If we double P, we must half V to get the constant value. If we double V, we must half P to get the constant value. If we triple P, we must reduce V by a third, and so on and so on. Based on that equation, you can obviously, by all means, please pause the video here and copy this information. This is very important. This is Boyle's law. And using this equation, I'd like you to have a go at these questions. Give yourself a good amount of time, 15 minutes or so. Show all your working out. Answers coming up in just a moment. And here are the answers. Please do pause the video, correct any mistakes if you've made any, and just double check how we got to the answers. Don't forget there were some conversions involved. In physics, units are converted. Please make use of those. Pause the video. Okay, and the last part I'd like to talk about is this idea. Work done on a gas. We know that gas is compressible. That means it can be squashed, because the particles are quite far apart. So there's a space for us to bring the particles together. We can compress the gas. But compressing the gas increases its temperature. This is why. When we use a force to compress a gas container, for example, if you think about a bicycle pump, we squeeze the air inside the bicycle pump, we compress it. What we're doing is we're actually carrying out work on the gas. Work done is a form of an energy transfer. So what we've done is we've transferred energy to the gas particles. And we know that when we transfer energy to gas particles, we make them move faster, we increase their internal energy, the gas gets hotter. That is very important to understand how this work done on the gas. We'll talk about work done in more detail in the forces topic, but this tells us that if we rapidly compress a gas, we do work on it. We're providing a force, we do work on it, and that work done is energy transferred, which gets transferred into the internal energy of the gas, which causes it to move faster, more kinetic energy, which means higher temperature. Please do get this down. And the final part, just some examish style questions. These do have varying difficulty and challenge in them, but try your best to get as many of these done as you can. Pause the video and answers are coming up soon. And these are your answers as to why. Please look at it carefully, think about it carefully as to why it's happened, correct any mistakes. And to end it off, here is our fact book summary again. Just a reminder of what we've covered in today's lesson. Thanks guys. See you next lesson. Bye.